Example 2 here, and this time the infinity or infinity indeterminate form, perhaps the second most popular form, right? Yeah, cool. And yeah, so what I want to point out to start here is in L'Hopital's rule, when we say limit as x goes to a, that a is allowed to be infinity or negative infinity. So I mentioned that in example 0, the intro video, but just want to reiterate it. Cool. And second is that we don't actually need to use L'Hopital's rule to evaluate this limit, right? We've learned in Algebra 2, pre-calculus, or wherever you learned this, that if you've got a rational function, a polynomial divided by another polynomial, and you're taking the limit as x goes to infinity, then what you're after is any horizontal asymptotes that that rational function might have, right? So here, you look at this rational function, we're trying to figure out if it has any horizontal asymptotes and sending the limit as x goes to infinity. Now, your teacher either gave you a set of rules for remembering horizontal asymptotes and what kind of horizontal asymptotes come in what kind of a situation, or he taught you how to think about them, which is even better. So if you just learned a rule, what you were taught was when the degree in the numerator is the same as the degree in the denominator, you take the leading coefficient in the numerator, which in this case is 1, and you divide it by the leading coefficient in the denominator, which in this case is 3, and that is going to be, y equals that number is going to be your horizontal asymptote, and therefore our limit here, a third, right? Cool. So you either learned that or your teacher taught you how to think, in which case he said, hey, sending x going to infinity is like working with really, really large x. And when you work with a really large x, then subtracting 4 from the numerator won't really have an impact. So this limit is the same as limit as x goes to infinity of x squared, because again, subtracting 4 won't have an impact for very large x. And then through similar logic in the denominator, subtracting 5 from the denominator won't have any impact, any measurable impact anyway. So the given limit is the same as this limit for very large x. And then this limit here is identical to this limit. Limit is x goes to infinity of 1 over 3. And since now we're taking the limit as x goes to infinity of a constant, we're just going to get that constant. And therefore, our answer would be a third, as we'd concluded based on our kind of rule that we were taught. Yeah? Cool. All right. So there are other ways to evaluate this limit. But let's apply L'Hopital's rule. So applying L'Hopital's rule once gives us the following, that we have limit, that L is poor, sorry guys. We have limit as x goes to infinity of 2x divided by, that horizontal sign was poor, sorry, 2x divided by 6x, right? Limit is x goes to a of derivative of the numerator divided by derivative of the denominator, because we got an indeterminate form when we evaluated it. I didn't show that, did I? So clearly, if you just evaluate it as is, you're going to get infinity over infinity, which is how we're allowed to use L'Hopital's rule. But you probably gathered by the title that that's what we're working with here. Anyway, yeah, so next we write that this is the same as limit as x goes to infinity of 2 divided by 6, which clearly is the same as limit as x goes to infinity of 1/3, a reduced version of 2 over 6, and this is, we've already said in red, is a third. And so our limit here is a third. Yeah? Cool. Now, I know that example 1 and 2 are fairly straightforward and so very light, easy examples, but there are much harder examples to come, so keep watching. We have to start somewhere, right? All right, take care.